Hello students. So in this video we are going to solve one more important typical example on the direct central impact. Now we have covered almost all types of examples in this chapter. So let us read the statement. Blocks A and B have masses 40 kg and 60 kg respectively. They are placed on a smooth surface and the spring connected between them is stretched 2 meters. So in the position shown, blocks A and B are connected by a spring which is stretched by 2 meters and they are kept on the smooth horizontal plane. If they are released from rest, determine the speeds of both the blocks at an instant that the spring become unstretched. So initially the blocks are stretched and they are held at rest, right? Now the blocks are released from that position. Being the spring is already stretched in the initial position and the blocks are released, the spring tends to regain its original length. In the process, the blocks will move towards each other. So when the spring becomes unstretched, you have to find out the velocities of both the blocks, right? So now, first considering the impact between A and B. It is a special case of impact. In the initial position, the velocities of both the bodies, means before impact, are 0. So when the system is released, they will start moving. Means after impact, the blocks will have the velocities. So before impact, the velocities of both the bodies are 0. So it is a special case of impact. So now, using law of conservation of momentum, that is m1u1 plus m2u2 is equal to m1v1 plus m2v2. Being the velocities of both the bodies before impact are 0, you have m1v1 is equal to m2v2. Of course, it is minus. Minus indicates that after impact, both the blocks or bodies will have opposite, they will move in opposite direction. The velocities are opposite. So here m1, that is mass of block A, is 40 kg into V1 is equal to m2 60 into V2. So this minus indicates the velocities are opposite. Okay. So this gives you V1 is equal to 1.5 V2. Relation between the two velocities. Right? Now the second step, using work energy principle. Work energy principle for the system. What is work energy principle? Change in kinetic energy. Final kinetic energy minus initial kinetic energy is equal to work done between the two positions. Now, what are the forces doing work on these blocks when the blocks are moving? Only the work done by friction spring force. Here, being it is kept on the smooth plane, the work done by friction is 0, and work done by the gravitational force 0. The work done by normal reactions 0. So only spring force is doing work, right? So this is equal to work done by spring force. Now, what is the kinetic energy of the system in the second position? Now we are using work energy principle for the entire system, right? Initially, when they are released from rest, velocity is 0, velocity of both the blocks. So the kinetic energy of the system in the initial position is 0. That means KE1 is 0. KE2 is the kinetic energy of the system in the final position. When the spring becomes unstretched, we are saying that is final position, position 2. So KE2 is half m1, right, into v1 square plus half m2 v2 square. This is the total kinetic energy at position 2. Kinetic energy of the system, kinetic energy of body 1 plus kinetic energy of body 2 minus initial kinetic energy is 0 is equal to work done by the spring force. So it is k by 2 into x1 square minus x2 square. Understood? So putting the values, 1 by 2, m1 is 40 kg into v1 square. See here, v1 is 1.5 v2. So putting that 1.5 v2 whole square plus half into m2, mass of block B is 60 kg into v2 square minus 0 is equal to k by 2. K is 180 Newton per meter. 180 by 2 into x1. What is the meaning of x1? Deformation of the spring in the first position. In the first position, the spring is stretched by 2 meters. It is given, right? The spring connected between them is stretched 2 meters. So x1 is 2 meters, 2 square. Minus what is x2? Deformation of the spring in the second position, final position. Means when the spring becomes unstretched, that means deformation is 0. So it is minus 0 square. Solving this equation, you get V2 as 2.19 meters per second, and putting it here, we will get V1 as 3.286 meters per second. So these are the velocities of the blocks B and A after impact. So the velocity of block A, that is V1, is towards right, and the velocity of block B, V2, is towards left. So both are moving in the opposite direction. Understood? Thank you.